Welcome to my talk, everyone. It's thrilling to be here with you. On the left, that's me, soaking in the incredible journey on the blue train from Kandy to Ella in Sri Lanka. An experience as exhilarating as diving into new realms in technology. Speaking of journeys, today we're embarking on an exciting trek through the enhancements in the Erlang shell and then exploring the frontiers of AI in programming. So why have this talk? As a new OTP developer, I want to introduce myself and also take the opportunity to try out speaking in public. In the last year, we have added new cool functionality to the Erlang shell, and we want to present that to you so that you don't miss it. And for those of you not familiar with the Erlang shell, but use another Beam language like Elixir, then many of the things that we've added may spill over to your shell as well. We also want to inspire and spark some ideas for how we can improve the developing environment for Erlang. This talk has also been a reason for me, or motivation for me, to take the plunge into the sea of AI, hopefully learning things we can apply to our workflow or to OTP. And here on the right is a teaser for what's to come later in the presentation, so hold on tight. Venturing into the world of OTP last year, you might recognize me as Frasse Jobb on GitHub. My journey began in Ericsson on developing a kernel for their embedded multi-core platform used in their baseband and radio products, and later I optimized their builds for this platform with Bazel. My fascination for programming languages started in the university with Haskell's purity and Prolog's logic, which opened my mind to other ways of programming. When I saw the internal job ad for Erlang OTP, I just had to apply. I also have an interest in automation, and now that the AI revolution has started, my mind is constantly on that, on how it will change society. I became a father last winter, so I am imagining all the possible ways I can use it to improve the life for my daughter. Now, imagine the shell as your command line cockpit, the control panel for the operating system, from the unassuming bash in Linux to Windows CMD. It's a programmer's launchpad, and then we have its close cousin, the REPL, your sandbox for real-time coding, testing, and debugging. It's a live, interactive coding experience. The Erlang shell has both shell and REPL capabilities. You can start, interact, and monitor processes running inside the Beam, and you can use it to prototype and debug. We already have a great environment in many ways, but there are many times you can find it lacking. So why evolve the Erlang shell? Because first impressions matter. A shell that invites exploration, simplifies testing, and eases debugging can be the difference between a developer embracing or abandoning a language. Our goal is to refine this experience to create a seamless transition from thought to execution, ensuring developers have everything they need within the shell's environment. Now, prepare to be entranced by the shell's evolution. Multiline editing now captures your code in its entirety. An external editor command that enabled coding in your favorite editor. And an advanced autocompletion that intuitively understands your coding intent, making your interaction with Erlang more intuitive, efficient, and enjoyable. Thanks to a refactored and improved backend, it has become much easier to add these new enhancements. You can also now expect the same experience for both Windows and Unix when using the shell. And you can start an interactive shell from your scripts whenever you need one. Now let's get into the demo. Let's see, if I can do it like that. Is it a good size on the text for you? Okay. Oh, sure. Let's. Is that all right? And how about the shell? Can it also be increased? Oops. There we go. Maybe it's a little bit cramped here, but all right. This is demo 2. We'll start with demo 1 here. All right, so let's assume you already have Erlang OTP installed and rebar free. I have squashed a bunch of bugs in this demo branch, so if you want to try this out yourself, expect that there are many things that won't work, but I will try to have them fixed until next week. All right, so now that we support multiline editing in the shell, the default keys we assign to the shell does not play nicely with Visual Studio Code. So we need to change that key map to something that works better. You could do it directly in VSCode, but I find it easier to do it in the shell. So let's start by creating a new config file for the key map. And here we can have a look at that. And basically, I'm overriding the default key bindings in the shell with saying that, I override the key bindings. And then here's all the functions that I'm able to set for these different key bindings. So when I add a new line, then it adds a new line in the expression. And when I do new line finish, then it tries to evaluate that expression. So here I change it so that it's on Alt-Enter, that it will send the command to the evaluator. But here are the important bits that Control P is already taken by VSCode, so I want to use B instead, and then I also want to do the navigation. So I will just copy and paste. Navigation in my multiline statement, which won't work because Visual Studio Code has overridden. It's catching all the Alt arrow key combinations. So then we have it here, just so that we have it there. And then let's continue and make sure that we have this rebar config. Yeah, we have that already. Great. So for the example here, I'm going to use JSX for JSON parsing. And now I will just update the environment so that I have persistent history and that I load this keyboard configuration on startup. All right, so now it begins. All right, so now imagine that we are prototyping some functionality for a function in a module in the shell. And once you got everything to work, you want to make it into a function instead. And then if the function is working, you can just copy and paste it into your module. We will add support for modules in the shell later. So I can start by typing something here. This is a big URL, so I will just copy just that one, and then I will copy the user agent as well, which I need for this thing here. Okay, why isn't it pasting? All right. There we go. All right. And then here we can see that it tries to complete some bindings for me. For some reason, that's correct. So then it can detect that. Where's my cursor there? So it can detect that we have this URI defined and the user agent defined, but then it also reads backwards to see over things that might not be in this table of already evaluated bindings. So it does some guessing as well. But so this is nice. We can just complete that one, but it was a short one, so it's. And then I'm just adding to this URI to help me for the later things here. All right, so now I want to do this HTTP request here with this new URI and with a user agent in the header here. All right, so let's do that. Yeah, we have modules as usual. That was old behavior. But you can also see now that I've added a pager so that you can see all of the different modules that's available. Some of them might be supposed to be hidden, but that's something we will add later to hide the internally exported functions within OTP. And you can also see registered processes here, if that's something that you would need at that moment. And then you can see the functions. And then we can see the type of the first argument for the different arities of this request function. And so to explain what this means here, that for the first one here, we have 4 arguments, the arity 4, and here's the return type. And this bolded argument here is what's these things here are what's it called? It's called expanded to. So this method here has this type that it can be either delete, get, head, option, patch, post, put, and trace. And for different arities, it's expecting a URL as the first argument. And I think that's the one. Now we're gonna use the get one here. And then you can see that now it expects the actual request. And I can see here that it expects a tuple with the URI string first. And then we have truncated what is supposed to come after that. Let's see. So then I'll put the URI here. Oh, actually, I was a tuple, sorry. URI, and then says that it's a list with a field, or a tuple. And then it's supposed to be a field of characters, normal byte characters, but I will actually put the user agent here. All right. All right, so that worked. So now we have the request here inside the body, or the response in the body, and then we'll do the next one here. All right. And this one expects the source, it's supposed to decode, so I will just put a binary in here. So list to binary, and then the body in here. And then I can see that it can be configured with different options here, but it actually is missing the one with labels. So, but I know that it's possible to do that, so I will just add that one. And because there can be a large amount of packages in this response here, I will want to just show one of them. All right, so here we have one package, and it's a lot of information here. But let's see what we can do with that. So this is something I just recently added, and we'll probably have to polish that a little bit more. But here we can have some auto-completion on the pattern matching. So then I could say that I'm actually interested in the name of the package, and I'm interested in how many downloads we have, and then I'm interested in the description. Okay, wait, it's inside the meta one. And then I want to see the latest version. Like that. And then, okay. And then I want to pattern match some more. And I want to do it one more time. Okay, so now I was able to parse this package out of this HTTP request, and I can probably do that for every package inside this request. So now I'm going to define a record that takes these attributes that I extracted from one of the packages. And then I can also make this into a function. So I will just copy this as well. All right, let's copy this one. I'm sorry about all the typos. I'm usually using another kind of keyboard, so now let's take this URI as well, add the term to it, and then basically I can just copy paste the whole function. But I want to show this as well. That except for showing the auto-completion, I also added this over command to show the documentation of the function, the module in this case. So if I want to investigate what kind of calls this module has, then I can read the whole documentation for that module, and then if I've found which function I'm interested in, I can read the help for that with by specifying the function and then calling this documentation keybind. And now I think I will just copy paste the rest of the function actually. Okay, let's see. Did I copy from the right place? HTTP request. Yeah, it looks correct. Yeah, so you can see that this terminal window is very small, but this expression is sort of paged already, so I can navigate here to go back if I want to change something that's any errors in here. So that's nice. All right, so now the function is defined, and then I can test it. Package kitchen, for example. Let's see what happened. Oh, it returns okay. That's because I have this statement here, which removes the output and just returns okay instead. So let's go back and fix that, and you can see that it took the whole multiline expression there. So that's an improvement. Then I can test the function again here. Yeah, so it seems to be working here. So now we have the result here, and with this record here, kitchen and kitchen sink and something called exvs. And then I think I also want to show you that you can also, oh wait, what's the package? You can pattern match on the record as well. I forgot to show you about that. And then what else is there? Yes, it's hard to see, but when I created this function, I can show you anyway. So I redefine this function again, and then I can just do something like this. And then if I submit this function again, it will automatically format this for me, so that you don't have malformed code which just confuses you. So now you can always copy paste something from some module that you've seen online on Stack Overflow or from ChatGPT or something, and then just paste it in, and then it will format it for you, and then you can read it and test it. And yeah, let's see, was there something else in this demo? Oh yeah, and then also I added a type spec for the. Well, I can copy paste these functions as well. Actually, you can define types, and you can define function specs, and then I can also use the auto-completion to get some kind of type type help for this function. So search, what's it called? Search packages. Then I can see here that it takes a number of search terms and then a match strategy. So I can say, all right, search for kitchen and search for JSX. And then choose the match one strategy. And then I've got a lot of packages here, matching both JSX and the kitchen keywords there. And I think that's the end of the first demo, yeah. Let's see. Now, exciting, isn't it? Right, I need to remove this window here. All right, so here are a couple of things that we might be able to add for OTP 27. It's maybe not planned, but if I have some free time over, I can probably add it. So we will add support for colors, syntax highlighting, and maybe coloring for the documentation, and errors and traces. Who knows what we will color? We can automatically format your code. We just saw that already, and maybe we can hide the internally exported functions in OTP so that you don't get a bunch of modules that you're not even supposed to see. We will also probably submit this paging mechanism that I think is very useful when you get a lot of results. We will, of course, do a lot of bug fixing and polishing. And then here are a couple of other ideas I've been thinking of. If we could, for example, add a visual hint after the cursor, like this in the first box, or if you could toggle between the different results in the auto-completion response, and just like the friendly interactive shell does it. And I'm also thinking about if we can pattern match in several overuse cases, for example, in case statements and such, and also pattern match on the type of the actual function on the right side. And hopefully also that you don't have to move the cursor back and forth, but instead it automatically writes the whole expression for you, and then you can have the cursor in place and continue to autocomplete the pattern matching. And here is a couple of things that might be coming after that in OTP 28 or later, because they require a little bit more effort. So we want to be able to define a whole module in the shell, and we want to be able to support for macros and parse transforms, and maybe collapsing output from previous commands to declutter your shell session, and add some kind of plugin system to enable different shell plugins like a VI mode or your own custom type formatter. And then maybe add a new debugger, record replay debugger using the powerful trace mechanism of Beam. And also I'm investigating LLM integration, and maybe we can add that for some use cases where we feel that it is helpful. And who knows, maybe we can integrate GitHub Copilot into the shell as well. How many are familiar with GitHub Copilot? It's about half of the people here. I forgot actually to show you something in the demo, so I will show that in the next demo. But all right, so we're working towards a shell that doesn't just respond, but anticipates, understands, and enhances your coding flow. Your insights could help you to sculpt the future of Erlang developing environment. So I encourage you to share your suggestions on this thread on the Erlang forums. Now, let's pivot to the world of AI, where large language models hold the promise of revolutionizing coding. Here are some use cases I thought would be interesting to try. So whenever I get an error, I want to have the LLM help me with that error and explain it, or maybe suggest fixes for it. And when I'm developing my app and I suddenly hear that, I see that, there's some kind of echo here. All right, so I want to be able to get package suggestions. So maybe I need a JSON parser, or I need some web framework or something, and then ChatGPT could automatically install it for me in my rebar config and reload the shell environment. Or when I'm lazy, I want it to code a function for me in its entirety. So let's look at the second demo here. All right, so difference here is that I have added a key here to talk with the large language model from OpenAI, ChatGPT, sort of. Let's add this to the environment, and then I don't think we have to do this. It's already loaded, and then yeah. So how many are familiar with ChatGPT? That's almost everyone. And in this demo, I made use of their API, which you have to pay for to use, to make my own ChatGPT app directly in the shell. And how it works is that you give the LLM a conversation between a user and an assistant, and then it predicts the next response from the assistant. Every time I make a call towards the LLM, I send the whole conversation again. The conversation acts as the memory for the large language model. And you also have what's called a system prompt, which kind of acts as the setting for the conversation, and it tells the assistant how it should act. And this demo is a little bit more shaky than the previous one, since you never know what you're going to get. Sometimes you get a really clean function that compiles and runs perfectly, and sometimes you get garbage. So we can try to make the same function we did in the first demo. But before doing that, I just want to show you a thing I missed in the first demo, and that's that you can open in an external editor. In this case, I open in VSCode from the shell. And if I have plugins in the VSCode environment or in my favorite editor, then I can make use of that when creating my functions. But I'm not going to demonstrate that much about this because we're going to use ChatGPT. But here I have what's it called? GitHub Copilot installed. So, for example, if I want to add a Fibonacci, is that one enabled? Okay, maybe I don't have the Copilot available, so we'll skip that for the demo. Well, that's unfortunate. But yeah, it's a very powerful tool to autocomplete your code inside your editor. And let's continue with ChatGPT instead. So I have prepared a prompt here to initiate the conversation. And hopefully ChatGPT will give me a function that works out of the box. First I'll... okay, maybe I don't have the correct key map here as well. It's supposed to be there. What happened? I have the key map there, yes. Oh, there we go. So this one is a little bit rough. It needs more polish, but here I can select which prompt I want to use. And this is a prompt inspired from another project on GitHub that makes it possible to run shell commands in the I don't know if anyone of you are familiar with it, but there's an open interpreter project where you can tell it in natural language what you want to do with your computer, and then it will give you the shell commands and it will control your computer for you. And so this one is a bit inspired by that, and but for this one it will create Erlang code instead, and let's see what it will produce. So here we have the prompt, and let's see. So now it sent the prompt here, and it's working. So we have to wait a little bit here. It takes a couple of seconds. And for those interested, it's using GPT 3.5 Turbo. It's faster and cheaper than GPT-4, so that's good, but it doesn't make miracles like GPT-4 can. All right, so now we got an error here. Let's see what's happened. All right, I don't know what happened, but let's try it again. See if it's. Well, it was a timeout. No, okay, yeah. All right, it's a little bit rough, so it needs polishing, but let's see, we'll try again. Usually I get it to work like at least 99% of the time, but well, in the meantime, we can just look at what function it's able to call. So we have this function feature of OpenAI, ChatGPT, and you can call functions such as here I have a run code function that says that it can run shell commands on my computer, and then I have a update rebar config function that expects the rebar configuration as its parameter, and then it will just replace the rebar config in my environment, and then I have some code that compiles the rebar config and then reloads everything. And I also have a function that calls update Erlang module, which also then expects the whole code as it's one of its arguments, and then it replaces the current module that I have in my source directories. And one for testing as well, but I found that it wasn't very good at making tests. So, all right, so here we have a response that seems to be better. So first it explains how it will accomplish the task, and we can skip that for now. It's similar to how ChatGPT works. What's interesting is actually the function here. So it has then made this module called search hexpm, and it's have this function here. Let's see, it's trying to use Jiffy here, and doesn't have a user agent in the thing here, but let's then tell it that yes, you are allowed to run this code on my computer. So it put that in my source directory, and then it recompiled everything, and now the prompt didn't show, but it's there. So let's see, it's called search hexpm, and then it's called search, and then I can say like search for kitchen. And then it said that an exception happened, and probably because it was missing the user agent here. So now it makes an error report and sends it to the group leader, and then it forwards that to the LLM. And then the LLM then analyzes the error report, and then it says that, yeah, okay, so apparently I was waiting for more messages here, and I was searching. I was using this function a little bit too early, so now I broke the demo here. But so it's supposed to then say that, oh, I see, I'm missing the user agent. I will just add that. And then you will try to run it again, and you will see that, oh, Jiffy is not installed. And then it can automatically then update the config and say that, well, now you have Jiffy, try it again, and etc. Then you have this loop working with ChatGPT. And I think that's enough for the demo because I'm going over the time here. Let's see if I can find that. There we go. All right, so to summarize the results of my experience during the last couple of weeks is that there are still limitations to overcome. Oftentimes I need to iterate several steps, which can make it quite expensive. And trying to make it more robust with a bigger starting prompt made it slower. And you all experienced it. It was very slow to give you a response. And other strategies have to be considered and explored, like finely tuning for Erlang and making use of several agents communicating. But we will get cheaper and faster LLMs very soon, hopefully in November 6th, and then I can make a better GPT assistant. And maybe in the future you can orchestrate a network of LLM agents directly in your shell. As we reach the end of today's journey, remember this is a collective expedition. Whether through enhancing the shell or pioneering with AI, your feedback, insights, and contributions are steering the ship. Let's continue this dialogue beyond today on the Erlang forums to shape a tool that will help you bring your ideas to life. Thank you.
All right, thank you, Lucas. I think we're running over time, so I guess Q&A will be on Wova app, and then you're going to answer it on the app.
Yes, and feel free to just poke me outside. I'm a little bit shy, but if you want to talk ChatGPT, Shell, or OTP, then just poke me, and then we can have a small conversation. All right, thank you.